Hello everyone. So we are continuing to solve 10th grade math board paper for the year 2019 and this is set 31-1. So it's the set 1 for 31 and series is JMS/1. We have already finished doing section A and section B in our previous videos and now we need to move to section C. It has 10 questions of 3 marks each and 13th question we have to prove that root 2 is an irrational number. To prove that root 2 is irrational, we are going to use the contradiction method here. So we can say let root 2 be a rational number which can be expressed in the form P by Q, where P and Q are co-prime integers. And Q is not equal to 0. Therefore, we can write down root 2 is equal to P by Q. Now squaring on both sides. We get 2 is equal to P square by Q square. P square is equal to 2Q square. Therefore, P square is divisible by 2. So we can say P is divisible by 2. Let P is equal to twice T. I am taking 2T because I know P is divisible by 2. Now again squaring on both sides. We get P square is equal to 4T square. Now substituting P square is equal to 2Q square from the previous thing. We get 2Q square is equal to 4T square, or I can say Q square is equal to 2T square. Q square is divisible by 2. Therefore, Q is divisible by 2. So let this be the first and this be the second statement. So from first and second, we know P and Q both have a common factor 2. Therefore, P and Q are not co-prime. And this contradicts our assumption. Therefore, root 2 is irrational. Hence proved. The 14th question. In this we have to find the value of k such that the polynomial x square minus k plus 6x plus 2 multiplied by 2k minus 1 has sum of its zeros equal to half of their product. In this question we are given a equation x square minus k plus 6x plus 2k minus 1, and we are given that sum of its zeros is equal to half of the product of zeros. And we have to find the value of k. Now here in this equation we know a is equal to 1, b is equal to minus k plus 6 and c is equal to 2 into 2k minus 1. Now sum of zeros is equal to minus b by a, and that is equal to half of product of zeros is c by a. So we'll substitute the values now. So minus b I can substitute as minus k plus 6. So minus minus becomes plus, and k plus 6. A is 1 is equal to half, and c is 2k minus 1, and a is 1. So we can cancel these and we get k plus 6 is equal to 2k minus 1. 2k minus k is equal to 6 plus 1. So k is equal to 7. Answer. Now the 15th question. It says a father's age is 3 times the sum of the ages of his 2 children. After 5 years, his age will be 2 times the sum of their ages. Find the present age of the father. Here we are given that a father's age is 3 times the sum of ages of his 2 children. 3 times child 1 plus child 2. After 5 years, so father will grow by 5 years and his age will be 2 times the sum of their ages. 2 times the age after 5 years. Both children will also grow 5 years. So C1 plus 5 and child 2 plus 5. Father after 5 years will be 2 times C1 plus C2 plus 10 years. So this is the information we are given. Now we have to find the age of father. So let father's age be x, and we are given that the sum of children age is equal to 1/3 of father's age. Now after 5 years, father will be x plus 5 and he is equal to twice the age of children. Then so twice, and the previous age was 1/3x, and 5 years are added to both, so plus 10 I can write down. Now we have got an equation. Let's solve it. So x plus 5 is equal to 2 into x plus 30 by 3. So thrice x plus 5 is equal to twice x plus 30. Now 3x plus 15 is equal to 2x plus 60. Now 3x minus 2x is equal to 60 minus 15. So x is equal to 45. Answer. The present age of father is 45 years. Now there is a choice in the 15th question. So the OR question says a fraction becomes 1/3 when 2 is subtracted from the numerator, and it becomes half when it is subtracted from the denominator. Find the fraction. Let the fraction be x by y. If 2 is subtracted from the numerator, so x minus 2 by y, it becomes 1/3. Cross multiplying will get 3 into x minus 2 is equal to y, 3x minus 6 is equal to y, or 3x minus y is equal to 6. This is the first equation. Now secondly, they say it becomes half if 1 is subtracted from the denominator, so x by y minus 1. Now cross multiplying, 2x is equal to y minus 1, 2x minus y is equal to minus 1. This is the second equation. Now equating 1 and 2, 3x minus y is equal to 6 and 2x minus y is equal to minus 1. Minus, this becomes plus, and this gets cancelled. X is equal to 7. Now substituting the value of x in second equation, we get 2x minus y is equal to minus 1. 2 into 7 minus y is equal to minus 1. So 14 minus y is equal to minus 1. Y is equal to 14 plus 1. So y is equal to 15. We got x as 7 and y is 15. So answer, the fraction is 7 by 15. The 16th question. In this we have to find the point on y-axis which is equidistant from the points 5, minus 2 and minus 3, 2. In this question we have to find a point on y-axis which is equidistant from, let's say this point A, 5 and minus 2, and the second point, let it be B, minus 3 and 2. Let the point on y-axis be, it is on y-axis, so x coordinate will be 0 and y. Let this point be P. We are given that this point is equidistant from A and B, so we can say AP is equal to BP. We are going to use the distance formula. So distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. AP will be 0 minus 5 whole square plus y plus 2 whole square, and BP is square root of 0 plus 3 whole square plus y minus 2 whole square. Squaring on both sides, we get 0 minus 5 whole square plus y plus 2 whole square is equal to 3 square plus y minus 2 whole square. Now this is minus 5 square, so 25 plus y square plus 4y plus 4 is equal to 9 plus y square minus 4y plus 4. Y square gets cancelled, and we have 4y plus 29 is equal to minus 4y plus 13. So 4y plus 4y is equal to 13 minus 29. 8y is equal to minus 16. So y is equal to minus 16 by 8. So we get as minus 2. So y is equal to minus 2. So answer, the point on y-axis is 0, minus 2. 16th question also we have a choice. So the other or question is, the line segment joining the points A, 2, 1 and B, whose coordinates are 5 and minus 8, is trisected at the points P and Q such that P is nearer to A. If P also lies on the line given by 2x minus y plus k is equal to 0, we need to find out the value of k. In this question, we have 2 points A and B, and there is a line segment joining them. The coordinates for A are 2 and 1, and coordinates for B are 5 and minus 8. And this is trisected at points P and Q. So AP, PQ and QB are equal, trisected, and P is nearer to A. So now the ratio of AP is to PB will be 1:2. Now here we need to find out the coordinates for P, and we are going to use the section formula. Section formula, coordinates of the point which divides the line is equal to m1 x2 plus m2 x1 divided by m1 plus m2, and the y coordinate will be m1 y2 plus m2 y1 divided by m1 plus m2. Now let's substitute the values. So we have xy as m1 is 1 and x2 is 5, so 1 into 5 plus m2 is 2 and x1 is 2 divided by 1 plus 2, and the y coordinate will be 1 and y2 is minus 8 plus m2 is 2 and y1 is 1 divided by 1 plus 2. Xy is equal to 5 plus 4 by 3, and this becomes minus 8 plus 2 by 3. Xy is equal to 9 by 3 and minus 6 by 3. This gets cancelled by 3 and this is minus 2. So x, y coordinates are 3 and minus 2. Now we have to find the value of k if the point P lies on the line whose equation is 2x minus y plus k is equal to 0. Now we know x is 3 and y is minus 2 plus k is equal to 0. So we have 6 plus 2 plus k is equal to 0. So k is equal to minus 8. Answer. The 17th question. In this we have to prove that sine theta plus cosec theta whole square plus cos theta plus sec theta whole square is equal to 7 plus tan square theta plus cot square theta. In this question we need to prove that sine theta plus cosec theta whole square plus cos theta plus sec theta whole square is equal to 7 plus tan square theta plus cot square theta. Now let's start solving the left hand side. So here I can open the bracket using a plus b whole square identity. So we have sine square theta plus cosec square theta plus twice sine theta cosec theta cos square theta plus sec square theta plus twice cos theta sec theta. Now this is sine square theta and cos square theta will become 1. This cosec square theta I can write down as 1 plus cot square theta plus 2 sine theta, and cosec theta I can write down as 1 by sine theta plus sec square theta I can write down as 1 plus tan square theta plus 2 into cos theta, and sec theta is 1 by cos theta. The sine theta gets cancelled, cos theta gets cancelled. We get 2, 4, 6 and 7 plus cot square theta plus tan square theta. This is equal to right hand side, so hence proved. Now here too in 17th question we have a choice. So the other or the or question, we have to prove that 1 plus cot A minus cosec A multiplied by 1 plus tan A plus sec A is equal to 2. In this question we have to prove 1 plus cot A minus cosec A multiplied by 1 plus tan A plus sec A is equal to 2. Now solving the left hand side, first we'll multiply the second trinomial by 1. So we have 1 plus tan A plus sec A. Now cot A with all the three terms. So plus cot A plus cot A tan A, this will become 1, and plus cot A sec A. Now all the terms with cosec A, so minus cosec A minus cosec A tan A minus cosec A sec A. In this step, let's convert everything into sine and cos. So 1 plus tan is sine A by cos A. Sec A is 1 by cos A plus cos A by sine A, and cot A into tan A becomes 1, so plus 1 plus cot is cos A by sine A multiplied by sec A, so sec is 1 by cos, so multiplied by cos A. Then cosec is 1 by sine A minus cosec A is 1 by sine A multiplied by tan A, so sine A by cos A, minus cosec is 1 by sine A multiplied by 1 by cos A. So here cos A gets cancelled and sine A gets cancelled. Now we have 1 plus sine A by cos A plus 1 by cos A plus cos A by sine A plus 1 plus 1 by sine A minus 1 by sine A minus 1 by cos A minus 1 by sine A cos A. Now plus 1 by cos A minus 1 by cos A gets cancelled, and plus 1 by sine A minus 1 by sine A gets cancelled. We are left with 1 plus sine A by cos A plus cos A by sine A plus 1 and minus 1 by sine A cos A. So we get LCM as cos A sine A, and here we have 2 cos A sine A. This and this will be added, plus sine square A plus cos square A minus 1. I can write down this as 2 cos A sine A, and sine square A plus cos square A can be written as 1, then minus 1 divided by cos A sine A. Plus 1 minus 1 gets cancelled, we get, and sine A cos A gets cancelled with this, so we get 2. So this is equal to the right hand side, hence proved. Now the 18th question. In this we are given a figure in which PQ is a chord of length 8 cm of a circle of radius 5 cm, and with center O, the tangents at P and Q intersect at point T, and we need to find the length of TP. Here we are given a circle. PQ is the chord of 8 cm, and the radius of the circle is 5 cm, and the tangents at P and Q intersect at point T, TP we have to find out. Let's join PO. Let's name this point as R. This angle here is 90 degree, as OR is perpendicular to PQ, and this bisects this chord. Now let's write down what we have done. So join OT intersecting chord PQ at R. Therefore OR is perpendicular to PQ and bisects the chord. Therefore, PR is equal to RQ is equal to 8 by 2. So this is equal to 4 centimeter. Let TR is equal to X centimeter. So this is X centimeter. In triangle POR, PO square is equal to PR square plus OR square. So PO square is 5 square is equal to 4 square plus OR square. Therefore, OR square is equal to 25 minus 16 is equal to 9. OR is equal to 3 centimeter. So we get this as 3 centimeter. Now, in triangle PRT, TP square is equal to TR square plus PR square. TP square is equal to TR, we took it as X square, and PR is 4 square. This is the first equation. Now, in triangle POT, OT square is equal to TP square plus OP square. OT is x plus 3 whole square is equal to TP square plus OP is 5 square. X square plus 6x plus 9 is equal to TP square plus 25. TP square is equal to x square plus 6x and plus 9 minus 25. So TP square is equal to x square plus 6x minus 16. This is the second equation. Both are equal to TP square. So now we can equate. So equating 1 and 2, we get x square plus 4 square is equal to x square plus 6x minus 16. X square gets cancelled. 6x is equal to 16 plus 16. So x is equal to 32 by 6 or 3, and this is 16. X is equal to 16 by 3. Now we have to find TP square. Therefore, TP square is equal to x square plus 4 square. We'll substitute the value of x. So 16 by 3 whole square plus 16. Now here we have 16 into 16 by 9 plus 16. Now I'll take the LCM. So I get 16 multiplied by 16 plus 16 multiplied by 9 divided by 9. 16 I can take common, and here I have 16 plus 9 by 9. 16 multiplied by 25 by 9. Therefore, TP is equal to square root of 16 into 25 by 9. TP is equal to 4 into 5 by 3. So, TP is equal to 20 by 3 centimeter. Now, the 19th question. In this, we are given a figure of triangle in which angle ACB is equal to 90 degree and CD is perpendicular to AB. We need to prove that CD square is equal to BD into AD. In this question, we are given a right angled triangle ABC, which is right angled at C, and we have CD perpendicular to AB. Now we need to prove CD square is equal to BD multiplied by AD. Triangle ABC is similar to triangle ACD, as angle A is equal to angle A common. Then we have angle ADC is equal to angle ACB. Both are equal to 90 degree. So by AA property of similarity. Now triangle ABC is also similar to triangle CBD, as angle B is equal to angle P, because that's the common angle here. Angle BDC is equal to angle ACB is equal to 90 degree. So therefore these two triangles are also similar by AA property of similarity. Let this be the first equation and let this be the second similarity. Now from first and second we can say that triangle ACD is similar to triangle CBD, because both are equal to triangle ABC. Therefore we can write down the ratio of the sides. AC by CB is equal to AD by CD is equal to CD by BD. Now as AD by CD is equal to CD by BD, so we can say CD square is equal to AD multiplied by BD. Hence proved. In 19th question too, we have a choice. So the other question is, if P and Q are points on sides CA and CB respectively of triangle ABC, which is right angled at C, we need to prove that AQ square plus BP square is equal to AB square plus BQ square. In this question we are given a right angled triangle ABC, which is right angled at C, and P and Q are points on CA. P and Q, we have to prove AQ square plus BP square is equal to AB square plus PQ square. Let's join. So this would be AQ and this is BP. We need PQ also, so this is PQ. This is right angled here. So now we can say in triangle BPC, according to Pythagoras theorem, we have BP square is equal to PC square plus BC square. And in triangle AQC, we have AQ square is equal to AC square plus QC square. Now let this be equation 1 and let this be equation 2. Adding 1 and 2, we get BP square plus AQ square is equal to PC square plus BC square plus AC square plus QC square. Therefore AQ square plus BP square is equal to, now for PC square and QC square, I can write down as PQ square. PC square plus QC square is equal to PQ square, and AC and BC square I can write down as AB square. Hence proved. In 20th question, we need to find the area of the shaded region in which we have a circle and there is a rectangle ABCD of sides 8 cm and 6 cm, and O is the center of the circle, and this is lying on the diameter. We have a circle and we have a rectangle here ABCD, which has sides 8 cm and 6 cm, and this AC is the diagonal and it is also the diameter of the circle. O is the center of the circle, and we have a shaded region here. we have to find the area of the shaded region. So this will be equal to area of circle minus area of rectangle. Now area of circle is pi r square minus length into breadth. Now we do not know the radius, so let's find out the radius. As AC is the diagonal of the rectangle, so I can say AC square is equal to AB square plus BC square. AC square is equal to AB is 8 square and BC is 6, so 6 square. AC is the diameter, equal to square root of 64 plus 36. So D is equal to square root of 100. D is equal to 10. So radius will be equal to 10 by 2. So we have 5 centimeter. So we'll substitute here, and pi we have to take as 3.14 multiplied by radius is 5. So 5 into 5 minus length is 8 and breadth is 6. So we have 3.14 multiplied by 25 minus 48. 25 4 is 100 and 25 35 3 75 78.50 minus 48. So we get 30.50 centimeter square. So answer, the area of the shaded region is 30.50 centimeter square. 21st question. In this, there is water in a canal which is 6 meter wide and 1.5 meter deep, and the water is flowing with a speed of 10 km per hour. And how much area will it irrigate in 30 minutes if 8 centimeter standing water is needed? In this question, we have a canal. So it may look like this, like a cuboid. Width is equal to 6 meter and depth or height we can say is 1.5 meter, and it is flowing with speed is equal to 10 kilometer per hour, and we have to find the area it will irrigate in 30 minutes. So time is equal to 30 minutes, and if 8 centimeter standing water is needed, volume of canal in 30 minutes is equal to volume of area with 8 centimeter water. Volume of canal I can denote by L into B into H, and this is equal to volume of area in the field, right? So length into breadth into height. Here we have distance is equal to speed into time. Here I can find out the length of the canal. Now length of the canal, so speed into time, speed is 10 kilometer per hour, so 10 I'll convert into meters, so 10 into 1000 divided by into minutes, so 60 minutes, and I have to find for 30 minutes, so I'll multiply by 30. So this gives me the length of the canal. Then breadth or width is given as 6 meter and height is 1.5 meter. And on this side, length into breadth will be area, which we have to find out, and height is given as 8 centimeter. So convert into meters will give me divided by 100. So now everything is in meter and minutes. So let's solve this equation now. So this is 1 and 2, 1 and 5. Now A is equal to 5000 into 15 into 6 is 90, 1 decimal point, so 9, and we'll bring 100 this side and also 8. Now this is 4 2 times and this is 25 times, and this is 2500. We get this as 62500 multiplied by 9. This is equal to 18 and 422, 256 meter square. So answer we can write down as it will irrigate the area of 562500 meter square. Now the last question of this section. In this we are given a table of frequency distribution and we need to find the mode for this distribution. In this question we are given a table with frequency distribution. We have class and we have the frequencies here. So class intervals are 0 to 10, 10 to 20, 20 to 30, then 30 to 40, 40 to 50, 50 to 60, and 60 to 70. This is 8, 10, 10, 16, 12, 6 and 7. And we have to find the mode of this distribution. For mode, we have to find the modal class. So this will be the modal class as it has the highest frequency. So modal class is 30 to 40. Now let's write down the formula for mode, that is lower limit of the class limit plus frequency of the modal class minus frequency of the class before the modal class, and divided by twice frequency of modal class minus frequency of the class before the modal class, then this is after the modal class. So we are multiplied by the height. So this is F1, this is F0 and this is F2. Height we know is 10, lower class limit we can find out. So now mode will be equal to lower limit is 30 plus frequency of modal class is 16 minus 10 F0. Then we have twice of the frequency, so 32 minus 10 minus 12 multiplied by the height. So height is 10. Now this is equal to 30 plus 16 minus 10 is 6 and 32 minus 22, that gives me 10 multiplied by 10. 10 gets cancelled. So this is equal to 30 plus 6. This is equal to 36. Now answer I can write down as the mode is 36. So with this question we have finished section C, and we are going to do section D in the next video. So stay tuned and see you all.